exponential derivatives, chain rule, Lagrange's notation. So, when you have an exponential, in this case we're working with a and to a power of x, when you derive that, you get ln of a multiplied by a to the power of x. So, a is a number, like 7, 6, 10, 1000, and it's to the power of an unknown. That's why it's x. Now, when you derive that, you get the exact same a to the power of x, but you multiply it by ln of a, or ln of that number. I'll show you an example just after this, but here is just a rehash of the chain rule I've done in previous videos, where you have a function hx, and within that you have a function gx within the function f of gx. And when you derive hx, you get the derivative of the outside function while the inside function stays the same, multiplied by the derivative of the inside function. So let's do an example. This example won't be the chain rule. This will just be showing you how the a to the power of the x works. So let's say we have a function and it's 10 to the power of x. When we derive that function, we have 10 to the power of x, but we multiply it by ln of 10. Just like before, a to the power of x, you derive it, you get ln of a multiplied by a to the power of x, 10 to the power of x. When you derive it, you get ln of 10 multiplied by 10 to the power of x. That's just the rules we're following for these examples, and that's as simple as it. I will do a proof video on how that happens, but not today. Let's start with an example for the chain rule. So, let's say we have hx sine 10 to the power of x. So here we have a function gx within the function f of gx. Let's say gx, the innermost function, is 10x. Because 10 to the power of x, because 10 to the power of x is the innermost function here. So f of gx would be sine gx. Oh, it's not going to fit. So we have, all I did was just substitute gx for 10x, because I renamed it. And now, if we write the formula for the derivative of hx is the derivative of f with respect to gx multiplied by the derivative of gx. So, find the derivative of gx. We know the derivative of 10 to the power of x is ln 10 times 10 to the power of x. And we know that, hopefully if you're watching this far into the playlist, you should know that when we're deriving sine x, you just get cos x. Or in this case, cos with respect to gx. So if we fill this in, what we end up with is cosine gx multiplied by derivative of gx, which is ln 10 multiplied by 10x. If we fill in gx and rearrange it a bit, we'll bring the 10x out we'll bring the ln 10 10x cos sub in gx, gx is 10x, and that is your first derivative, following the chain rule and using the methods I showed you before. For another example, let's say hx equals 7 to the power of x squared plus 1. Here we have our function x squared plus 1 within our function 7 to the power of x squared plus 1. So our innermost function is gx, so we'll label gx as x squared plus 1, and our f of gx is our outermost function, which is 7 to the power of gx. When we go to derive this, we need to find the derivative of f with respect to gx and multiply that by the derivative of gx. Derivative of gx, x squared plus 1, the derivative of that is just 2x. F dash gx, the derivative of 7 to the power of gx, I'll write that down here so I can fit it in, is ln 7 multiplied by 7 to the power of gx. Still couldn't fit it in. So, same as what I did before, 7 to the power of gx, just like the same as 7 to the power of x. You leave 7 to the power of gx the same, and you multiply that by ln of 7. If we fill this in, f dash gx ln 7 multiplied by 7 gx, multiply that by derivative of gx, which is just 2x, and I'm not going to simplify it any further. You can rearrange it to however you want it to look. I think it looks fine, so I'm going to leave it and do another example. So here we have hx equals negative cosine 7x plus x squared. Again, we have a function within a function, gx within f of gx, 7 to the power of x plus x squared within negative cos of 7 to the power of x plus x squared. Give myself a bit more room. So, gx we'll label 7 to the power of x plus x squared because it's the innermost function. And f of gx we'll label negative cos gx. Formula for the derivative is f dash gx multiplied by g dash x. We need to find g dash x, and we need to also find f dash of gx. Gx being 7 to the power of x plus x squared, the derivative would be ln 7 multiplied by 7x plus 2x. What I did was I worked on one side that when you have 7 to the power of x and you derive it, you get ln 7 multiplied by 7 to the power of x, and on this side when you derive x squared you get 2x. So that's what I did. Ln 7 multiplied by 7 to the power of x plus 2x. The derivative of negative cosine is just sine gx. If we fill this in, f dash gx sine gx multiplied by g dash x. I'll rewrite this, put it all nice and neat. Sine gx, I'll fill in the gx now, multiply that by g dash of x, ln 7 multiplied by 7x, 7 to the power of x plus 2x, and that is your first derivative of this up here. Thanks for watching. I hope this helped.